Hello everyone, welcome to my new science school physics class. In this class, we are going to discuss position and reference point. When we say position in English, we simply mean location of an object, that is location and placement of an object or body. That's just position. But when it comes to physics, you need to consider other things, because for you to define position or position of an object in physics or in science generally, you need to know from where are you talking about, which is the reference point. You cannot say where something is unless if you have the reference point. Talking about position here, we are just referring to place, or we are just referring to distance from a point. We are not just saying position, just how something is placed. No, the location of an object. That location will be defined using the reference point. What is reference point? Now let's talk about it. Reference point. Reference point is a point where all your measurement will start from. Reference point. A simple question can be asked, like to say, how far is Kano? When I say how far is Kano, you cannot answer. Why? Because the question is not complete. For me to complete the question, I need to put the location of the start of the measurement. That is, from where. If I say Kano, yes, this is Kano, and let's say this point is Kano. And is Kano very far? It depends. Kano is very far from, let's say, Katsina. Yes, we can accept that. But when you are comparing the distance from Katsina to Kano, or Kano to Katsina, and from Kano to Lagos, now Kano to Katsina is not as far as Kano to Lagos. So telling someone how far is Kano, you need to know the reference point. That is, from where do you want me to calculate for you, or you want to tell me, or from where do you want me to tell you how far is the Kano? So Kano to Kaduna, let's say Kano to Kaduna. Kano to Kaduna. How far is Kano to Kaduna? Then now it's complete question. Then you can answer by telling the kilometers in between the two cities. And from a reference point, you can measure distance of different objects. No matter how far or close they are. But without reference point, you cannot measure any distance. You cannot measure the location of an object. From Kano, for example, when I do not complete the question, if I ask, how far is Kano, and I just kept quiet, that means the question is not complete. And people will be wondering, is it from Lagos? Is it from America? Is it from, let's say, a village close to Kano? Nobody can tell, and nobody can answer the question correctly, because I did not give you the reference point. But the moment I said, how far is Kano from Kaduna, then I give you reference point. Reference point are like starting and ending point. Let's talk about it using digit. Let's say you have point A and point B. let's say this is point A and this is point B, and in between them is a distance, and this distance, let's say we have 0 here, we have 1, we have 2, we have 3, 4, 5 and 6. Now let these numbers to be in kilometers. So we have 0 kilometers to 6 kilometers. Now if you want to count the distance between point A to point B, then you confidently say it is 6 kilometers, because you are calculating from point A to point B along this line. So now let's put formula. How do we calculate, or how do you get 6 kilometer? What we did to get 6 kilometer is just simple calculation, because here is simple calculation. We use our head to calculate this, but for us to develop formula for this, we'll just say the formula for calculating the distance of an object location from a reference point is just by using formula, or by subtracting the final destination, that is the location of the object, minus the reference point. Here we have numbers in each of the points. We have 6 at this point, we have 0 at this point A. So now for me to calculate the distance, I'll just say the distance is let's say distance is D. Let's say it's equal to okay, let me just write it in full so that it will not confuse us. Distance is equal to the final destination. Let me put FD as final destination to minimize space and time, minus final destination minus starting point. If we subtract starting point from final destination, then we will get the distance of the body from the reference point. How do we do that? Oh, how do we get 6 here? It's just by saying final destination. What is final destination? Is the point where that object is away from the reference point, which is here. Our reference point is already this, which is 0, which is A, and final destination is C here, which is B. Then final destination is B, which is 6. Let me just write 6 not to waste our time. 6, then minus what? Where A is 0. 6 minus 0. 6 minus 0, you will end up getting 6. So we have 6 kilometer. This is how we got the 6 kilometer. So our reference point is what? 0. But this reference point must not be always 0, because you can calculate. Let's say we have another point, which is C. So for you to calculate a distance between C and B, or let's say a body moves from C to B. When this object moved, then we can calculate the distance by applying this formula, which is distance. Let me write this for distance. Distance is equal to final destination minus starting point. Final destination, here you started from C to B, then your final destination is B. Then we have B, which is 6. Let me just write 6 minus 2, which is equal to 4 kilometer. This is very, very important in knowing reference point. So we have 4 kilometers as the distance of the object. So let me give the last example here. Let's say our final destination is here, D. If you are to ask, if you are asked to calculate the distance between, or if an object moved from this point, which is C, to D, what is the distance between, or what is, or how much kilometers, or how many kilometers rather this body covered? To calculate that, you say distance, just apply the formula, is equal to final destination minus initial destination or starting point. Now we have the body started from this point to this point. We have C to D, where C is at 2 kilometers, then D is at 5 kilometers. Now you have 5 is the final destination minus 2. At the end, you end up getting 3 kilometers if you press your calculator. So this is just how to calculate. This is just to tell you what is reference point. Reference point is a point where the measurement would start from. Without a reference point, that means you don't have a ground to start your measurement. You must have a ground to start the measurement. That ground is the reference point. That's why somebody will just use a tape that is, you will not even start with 0. Instead of starting with 0, just go to 12, and maybe you want to measure 6 centimeters. You just start from 12. Maybe this is the tape. Okay, let me draw something like this as the tape. Okay, let's say sorry, let's say this is our tape. Maybe this tape is very long. This is the calibration of the tape. So if you want to measure, let's say this is 2, this is 3, this is 4, this is 5, this is 7, this is 8. For example, this is our tape. If you want to measure distance of, let's say, 3 centimeters. Let's say this is in centimeters. So you just use from 4 to 7, and from 4 to 7 is what? Is 3 centimeters. So instead of him using from 0 to 3, you just use the middle of the tape, and it's still the same measurement. If you know the reference point, then that's all. Because when he place a point here and here, and he can calculate the distance between these two by saying final destination. Let's say we start from 4 to 7, then the final destination is 7 minus initial destination, which is 4. At the end, he has 3 kilometers. That's all. Now that you understand what is reference point, how important it is, let's talk about position. For us to know position in space, we usually use 2 dimension. What is 2 dimension? 2 dimensional. In 2 dimension, we are always using this axis. This is simply graph. So we have here, let's do it one by one. We have here 0. This is 0. Here is 1. Here is 2. Here is 3. And here, since this is 0, then anything that is going below is negative. So we have minus 1, minus 2, minus 2, minus 3. So this axis that stand vertical is called y-axis. We have two important axes we mostly deal with. These are vertical and horizontal. The vertical one is called y-axis. We call it y-axis, just to give it a name, y-axis. Then this part is positive, so we don't need to write y-axis again. And again, you will have horizontal line, which the line has a center. From this center is 0. Anything to the right, we have 1, we have 2, we have 3. All these numbers are positive. Going toward left, we have -1, we have -2, we have -3. This horizontal line is just number line. We did number line in our previous videos. If you like, or if you want to know more about number lines, you can check the video. So this line is also called axis, but for you to differentiate this line and this one, you need to give them different name. And the first one is vertical, this one is horizontal. Then the one that is horizontal is called x-axis. What is called x-axis? It's just number line. So for you to know position of an object, we need to integrate these two lines together. Because now in simple mathematics or in simple demonstration, now if we say our reference point is 0 and you want to calculate the distance of an object, let's say it's here, then you can just simply say it's 3 kilometers. And even it is on the negative side, you can, or you still use numbers as the positive. Here you can say when something is here, you can say it's 2 kilometers, but to the left. For you to indicate that left, you must use a negative sign. But you can't use negative sign by putting kilometer. You can't say -2 kilometers. That is impossible because there is no negative in terms of measuring length. So what you should do is just keep it as 2 kilometers in order to avoid confusion. But what if the object is here? Then this is 0. The object has not moved any direction. But the second thing, or the next thing that will cause issues, is that when this object, this is the center, yes, but the object moved to this part. Now, how do you read this on this scale? Probably you cannot, because if you trace down, you are still on 0. And if you go this way, this is not the right way. So that's why we use for any vertical movement, we use y-axis. Imagine this thing is here and you move or it moves up to this, then you have 3 on y. That's why we integrate these two lines together so that we get the accurate presentation in 2 dimensions. We talked about on I think on some of our lessons that dimension are another very important part that you need to know for you to understand science very well. So this dimension, let's integrate these two lines. Let me put x-axis here. So this x-axis, it will have 1, let's say 1, then 2, then 3, then 4. Then we have here as -1, -2, -3, and -4. Remember, this line is called x-axis. They usually put arrows on either side of the lines. So this is arrow. So we use these lines to coordinate, that is to find location, or to find a location of an object or a body. Now, how do we do that? Is when we place something here. Let's say somebody is here. If you are asked where is the location of this person, what you will say is that x is 2 on 2. Yes, x is 2, then y is 1. So you write the coordination of this object as open bracket 2. The first thing that comes after bracket is value, or x values, that is the value on the x axis, then comma, then value, or the value of y, we have 1, then close the bracket. So what is the coordination of this person, or why is this person? You can use these numbers to present that. You can say the person is located 2, 1. People will interpret, or scientists will interpret this as 2 on x-axis, then 1 on y-axis. So this is for the location. Then if somebody is there, then this is his position. Remember, here we are not calculating distance, even though you can calculate distance using a different method, especially the Pythagoras theorem. Pythagoras theorem, we are going to deal with it very well in our shapes and figures in mathematics, in a topic called shapes and figures, or plane figures. So let's say this object has moved from this point and come to this point. Now, the location of this person will be tracing here. Let's just try to keep it perfect so that it will not stress us. Let's write the 3 is here. So let's say it's on 3. Then here it is on 3 again, but this one is minus 3. That means for you to write the location of this person, you just open bracket and write minus 3, close bracket, then plus 3. The person that will see this is going to interpret it as the person is on negative side, or in let's say this in kilometer, 3 kilometer on the negative side, that is on the left hand side, and 3 kilometer to the let's say to on y-axis. Remember, these 4 axes can be, here can be east, this can be, or if this is east, then this one must be west, this one must be south, this one is north. This is very important for you, so you can now define the position of any of these 2 figures or 2 bodies using these numbers, and to indicate the direction where we can find them. So that is it for the position, and I hope you understand how to calculate position of an object with this simple axis, which is y, or which are y and x. These are the basis of graph, because if you understand how to use these 2 lines, that is x and y axis, to locate a point in this fill capacity, then that means you can draw a graph or you can plot a graph. So I will see you in the next lesson. This is just for you to learn position and reference values. Hope you understand it very well, and you can answer as much as questions as somebody is going to ask you on this topic. Thank you very much. See you in the next lesson. My name is Science School. As always, you can reach us through our WhatsApp, which is 081 28 14 18 and 16. This is our number. You can chat us on WhatsApp so that you can get a class to follow us properly. Thank you very much. See you in our next lesson.